planets and moons that populate the universe, only one is near enough to travel into our own planet.
Okay, well, we're going to start the show. I'm just going to have a few things sent to me because we can't actually see what you're seeing at the moment. But welcome. This is Slooh Space Camera and another one of our free public shows looking at another of these near-Earth asteroids. And this one, wow, we've been doing these for a few years now, but this one took a whole new bent on the story last night when it was discovered that this little asteroid has its own little asteroid orbiting it. So anyway, we have got an absolutely fabulous show tonight. We are going to be telling you all the way from scratch, all the way from nothing, what asteroids are, near-Earth objects, asteroids and comets are included in that. We're then going to talk more specifically about this particular asteroid, this potentially hazardous asteroid, which is named very nicely 1998 QE2. We're going to be talking about the consequences of what happens if one of these things were to hit Earth. We've had very recently the Russia event in February. Actually, when we covered another show, when we were looking at another, even closer near-Earth asteroid. Now, I've got some very esteemed guests with us tonight. I have Mr. Bob Berman, astronomy author extraordinaire. His latest book, The Sun's Heartbeat, is an absolutely fabulous read. So I'm going to hand over to Bob in a second. But at the top of the hour, we also have filmmaker and producer Duncan Kopp joining us. Now, Duncan's always fascinating, always has a different direction that he comes from. He's got a whole stack of contacts in the astronaut community and at NASA, so that will be very interesting to hear from him. Now, let me see. Unfortunately, I still don't see. I'm just telling our producer in the background, Mr. Patrick Palucci, he's producing the show tonight. I just need to let him know that neither Bob or I can actually see what our viewers are seeing tonight. But what I wanted to move on to very quickly, we know that we've got an awful lot of new viewers tonight, and they don't know who Slooh is. So I just wanted to give a very brief introduction. Who Slooh is. What are we? Well, Slooh.com, Slooh Space Camera, we're known as. We have a fantastic observatory, which our live images are going to be coming from this evening. High on top, 8,000 feet on top of a volcano in the Canary Islands, which is off the west coast of Africa. Hey, Mr. Producer, I've got some images. So you're seeing some images at the moment of the observatory site. It is home to some of the biggest and best telescopes in Europe, and I'll tell you, it is an absolutely fabulous site, and conditions tonight are brilliant to be viewing this really fast-moving asteroid. Now, we've got a number of telescopes there. We're going to be using both of those tonight to look at this asteroid live. So if you're on the home page, you can flick between the different views. Just one little bit of warning, the images from the half-meter telescope, that's our giant telescope, those are actually going to be starting at the top of the hour. So in about 25 minutes, that channel will come live. But once I've handed over to Bob, I'm going to be getting some live images straight from our other high-mag telescope. So anyway, Slooh has these telescopes on top of this volcano, this world-class observatory site. Who uses them? Anybody is the answer. Anybody who wants to. You can join up, you can get a membership to Slooh, and you can control these telescopes each and every night, which is exactly what our existing membership do. We also have, though, a brand new way of controlling those same telescopes, and that's through our new iPad app. The app is free to download. In fact, you saw probably a little, I didn't see that, but you saw at the beginning a little demo of that app. It gives you one-touch control of these fabulous telescopes on top of this mountain. So it really is cool. And it's Slooh memberships, it's people joining Slooh, it's people using the app. It supports this kind of programming that we bring you very regularly. We're not newcomers to this. We've been doing this since 2003, and we're a bit passionate. We want to get astronomy out to the masses, and this is a fantastic way of doing it through these live shows. We like to put things straight as well, because there's a huge amount of miscommunication out there. So, by the way, don't forget, you can contact us. You can on the Slooh homepage, press the Slooh Conversations button. Our producer, Mr. Patrick Palucci, he's going to be monitoring Slooh Conversations, so you can ask questions of me or Bob. But I'm going to disappear for probably 5 or 10 minutes just to make sure that we get the new live images streaming in straight to the homepage of this amazing asteroid. I was about to say little asteroid, 1998 QE2, but Bob, over to you. This is no small asteroid, is it?
No, it is not. And we've gone from covering, wow, in the last 2 years, even in the last single year, we seem to have been visited by near-Earth asteroids, it seems, once a month or so, and we've covered the passages live. One last July came 14 moon distances from us. The next one in September came 7.5 moon distances. We had one only a quarter of a moon distance, and one that was so close that it was 900th of one moon distance. This was that famous one that occurred on February 15th, on the same day that Siberia got clobbered by amazing coincidence, but this is by far the largest of all of them. It's passing about 15 moon distances from us, and so a safe separation, but it's far and away the largest, being 1.7 miles across. So this is the kind of thing we do not want to have hit us in space. And fortunately, it's not. In fact, its orbit around the sun, which is a little less than 4 years, it's got a 3.77-year orbit, making it more leisurely than Mars. And if you look at the shape of its orbit, at its farthest point, it ventures out beyond Mars. At its closest point, it just barely gets as close to the sun as we are. So if it reaches its near point to the sun, called perihelion, at the same time that we are passing by, then we get a close encounter, and that's what's happening now. It will not happen again for at least 200 years that we come close to QE2. I guess we can abbreviate it. Instead of calling it 1998 QE2, named for the year in which it was discovered, we'll just say QE2. That has a nice ring to it, Queen Elizabeth II. In fact, some of the media have been always comparing its size, 1.7 miles across, to how many Queen Elizabeth ocean liners would it take to line up to equal the size of this. And the new news that radar has discovered, this is just in the last couple of days, that it has a little moon of its own, about 2,000 feet wide, about a fifth of a mile across. This is not as fantastic and earth-shattering a discovery as some might think, because about one medium-sized asteroid in 6, one out of every 6, has its own little moon, and formed entirely different from the way the moons of many of the planets formed, which probably were born together with the planets. In this case, asteroids get hit, usually by other asteroids, and then pieces get broken off, and because of their mutual gravity, the piece doesn't get too far, so continues to stick around it and orbit around it. And we think that's the origin of virtually all of the moons of asteroids. So about 1 in 6 is a binary asteroid, or even a triple object in space. So this proves to be a binary. So that's kind of cute that you have an asteroid with its own little 1/5 of a mile across moon, which means something like 8 of these moons of this asteroid in a row would equal the size of the parent body. By comparison, Earth's moon, our own moon, is about 1/4 of our size. We've got a big moon compared to the size of Earth. 4 moons stretched across would equal 1 Earth width. Or in terms of mass or weight, 81 of our moons added together would equal the weight of Earth. But in this case, the ratio is more normal, and the moon is smaller relative to the size of the body. So, as we await full darkness at our Canary Island Observatory, and we're waiting for the first images to come, which will happen any minute now.
We've got them, Bob. We've got them.
Great!
The first image has just come through from what we call our T2 high mag telescope. So just to let everybody know, the images at the beginning will be a little bit noisy. That's just because the sky background makes those images noisy. But what you're going to see is the asteroid as a small star-like spot in the center of the image, and you'll see these other kind of streaks, white streaks on the images, and those are the stars in the background. And maybe, Bob, you can tell people exactly why we're seeing it like that. So,
Yes.
But could you also tell us as well, Bob, where do all of these near-Earth objects come from? Where are they hanging out? Why do we get so many coming so close to us?
Well, the reservoir of most asteroids are safely between the orbits of Mars and Jupiter. This was a planet that we used to think a planet that got destroyed. Science fiction books of the 1950s used to imagine a planet where the civilization blew themselves up via nuclear war or what have you. But we're now quite sure that this was a moon, an object, a body. It wasn't really that much larger than our moon. All the asteroids put together don't even equal the mass of Earth. That couldn't quite form because of the meddling of Jupiter's gravity. The tidal forces are just too great. So instead we have chunks of primordial material that solidified into stony or metallic. Some of them are nickel iron, some of them are stony, that are mostly between Mars and Jupiter. But because of collisions and other orbital mechanics, we get some that trespass closer than the Martian orbit, and some that even cross Earth's orbit. And these are called the near-Earth asteroids. These are the ones that we have to be careful of. And when we image them, as we're doing, as the Slooh telescope is doing, we can take individual images and show you the actual asteroid. That's what we'll be doing now. And then there's two ways to create a time-lapse image. Either we can keep centering on the asteroid, in which case, since it's traveling, if we keep the image of the asteroid centered, the background stars are going to have to keep moving or streaking and be in animation. Or Paul, who's controlling the telescopes, can make the telescopes track the background stars, in which case it'll be the asteroid that either streaks or moves. There's two ways to show it to you, but that's what we're starting to bring you now, as night has fallen over the Canary Islands observatories of the Slooh space cameras, and here they are, their first images.
That's right, Bob. And at the top of the hour, don't forget, the second live channel, the second live telescope feed will kick in. Probably a couple of minutes past 9. This is our half-meter telescope. Now, a half-meter telescope is enormous, and it collects so much light that we really need it to be dark. Darkness needs to fall. You can see, I think, if you're on the home page, if you click to what we call the all-sky camera, you can see that the sky is just still a little bit twilight. And the problem is that half-meter telescope collects so much of that light, it would kind of bleed out the stars and the asteroid. But what we're doing with that view for the half-meter telescope is where it's got a very big field of view. So we're going to keep it fixed, Bob, tonight on the same star field so that people can actually see the asteroid as it moves across the image from one image to another. Now the half-meter telescope doesn't update as often, as frequently as the T2 high mag does, but it's going to be two very distinct views there that we've got. So, Bob, this 1998 QE2, let's call it QE2 tonight. This was discovered, wasn't it, by our friends over at the MIT, the Linear Project, and
the Linear Project, and which has produced a number of discoveries. Fortunately they don't try to do their observing from MIT, which is all light polluted. They do it out west. And they've made a lot of significant discoveries, which is why there are comet linears over and over again, because the discoverer gets their name, even if the discovery is not a human being but a project. the name is assigned to the
We're doing it with
object.
that
So
view. But those guys are doing it, aren't they, as part of, I don't know exactly the terminology you guys use over in the States. I'm in the UK, controlling the telescopes tonight. It was a real global community at Slooh. But don't they do it through a congressional mandate? That's what they're doing, isn't it? Searching.
yes, and fortunately, just last year, Paul, the budget was increased from $6 million a year
Up
to
to 20, yeah.
$20 million a year. So, thanks to the publicity, and I'm going to boast a little bit that Slooh had no small role in it by showing all the near approaches and the near misses that we've had over and over again, and we know that the public has been very, very, very interested in this. So now it's not just a few backyard zealots who are looking for near-Earth objects that could possibly collide with us. Now there's enough of a budget, even though $20 million is, in today's money, not that huge, but it's enough so that now there are teams dedicated to searching for these objects. That's not what found this one this year. This one, as we say, was found way back in 1998. And with an orbit of almost 4 years, it has the potential to meet us every 4 years, but it actually doesn't, because after it's completed its orbit around the sun, since its orbit is 3.77 years, notice it's not an even number. Earth has an even number around the sun. We have exactly 1.0 year orbit. So if there was an object that had a 4.0 year orbit, it would meet us every 4 times we went around the sun. But 3.77 years, no, it means that once our paths cross again, the other one's not quite going to be here the next time. And so we tend not to meet, we do not meet every time QE2 gets to its perihelion, or closest approach to the sun, and in fact we are not going to meet again for at least 200 years. So this is a salute. The closest approach is occurring about 9 minutes from now.
That's right.
We've been tracking this for years, and 9 minutes from now is when it is closest to us, and we're showing it to you live.
One of the things about this particular asteroid that really kicked home to me, Bob, is, unlike, and you touched on a very important subject a minute ago, NASA's had their funding increased just last year. Now, we started this campaign back in 2007 to try and really show just how many of these objects are out there, how many haven't been discovered, and how many large ones are discovered when they're only days away from their closest approaches to Earth. But the thing that fascinates me about this one is that it was discovered in 1998, which is what its name tells us, but only last night we discovered something so fundamental about this object that it had this other small asteroid, satellite, moon, call it whatever you will, actually orbiting it. Isn't that amazing that we've known about this object for nearly 15 years and we find out something so fundamentally new about it?
Yes, of course, it's not surprising, because it has to come close for us to be able to see the detail either visually or through radar to give us the information. And this is an extraordinarily close approach.
Yes, which makes it incredibly valuable. That's why this thing first hit the headlines, because it's large and it's close, which means that for the scientific community, from observing from the radar point of view, and it's the radar images that actually give us the detail of the surface and accurate measurements of the size, and indeed it was the thing that discovered the moon last night. Those things have to both be there. The size has to be there, and it has to be close for us to be able to image these things with radar. But Bob, you picked on, you said once again about NASA having their funding head of NASA, and it's at a House Science Committee, which I believe is in your Congress, on the 14th of May. He said, launchers can either provide adequate funding for the detecting and characterization of near-Earth objects and diverting them if necessary, or they can pray. I just found that an absolutely staggering statement to have from a NASA official. But, maybe he's making the point. And what we embarked on last year, Bob, isn't it, with a lot of ferocity, was covering these near-Earth objects, some of them only a few days doing this, and suddenly the other media outlets started picking up on just how many of these things, how close they were coming, and I think consequently the kind of risk that Earth faces. Now, we're going to talk about that in the second half of our show. But I don't know, Bob. Do you think there has been a sea change in the way the media and the scientific community have kind of pricked up their ears over this last year?
I would say so, yes. And I think Slooh has a lot to do with it because we've been covering all the near-Earth near misses over and over and over again, and a lot of people were fascinated by it. But then there was the second event on February 15th of this year, and you know quite well that the fact that we went from one person in human history injured, and that was Ann Hodges in Silicoga, Alabama in 1954, who was fortunately not seriously injured by a chondrite, a meteor that came through her ceiling, bounced off a console radio, and hit her as she was lounging on a couch in Alabama. We went from that one person documented, there have been other claims, but this is the one that we're sure of, to 1,000 people injured, mostly by broken glass from the sonic boom produced by the Siberian meteor on February 15th of this year. That happened on the same day that we had an extraordinarily close approach by another asteroid 2012 DA14 out. That was one that's only 150 feet wide. Now this one's 1.7 miles wide, and yet it came only 9/100ths of the distance to the moon. That was very, very close, and that we should have had that Russian event happen on the same day. Well, if that is not going to wake people up to, hey, these things can happen, it really is like a video game out there. It's like Pong, or I guess it's more like the game Asteroids, come to think of it. You're old enough, Paul, to remember Asteroids as a video game.
Oh, well, I'm old enough and wise enough not to admit that I'm old enough to know that game.
Yeah. So suddenly we realize, this is really worlds in collision out there, and that all the craters that we see on the moon, which, by the way, we now know that the moon just 2 months ago on March 17th was clobbered by an object only a foot wide, but created a crater probably 60 feet across that created a flash. We covered that last week on our show, but these things are happening, and so here it is again today. This one's at a safe distance, but it's the largest of them in the last year. So yeah, you bet now suddenly Congress and others are interested in keeping track of them. We had a lot of Hollywood movies to this effect. You'll remember Deep Impact and a number of other fictional ones, and we've been told ever since Luis and Walter Alvarez, more than a quarter century ago, changed our thinking about how the dinosaurs became extinct at the KT boundary between the Cretaceous and Tertiary periods, when a giant impact hit the Yucatan Peninsula 60. We know that probably we humans wouldn't even be the dominant species here if it weren't for an impact. So here it is again. So we're watching it, and this is not fake stuff. It's real stuff.
Now, Bob, I am just changing the if it's shared in, our producer is sharing in the live images every now and again direct to the broadcast. But if you're on the Slooh homepage, you can switch between 7 minutes time, so at the top of the hour, so you can click over to the half-meter telescope view and see the asteroid live in as well. I've just increased the exposure time, so the stars in the background are actually streaming more. Now then, after we take a very short break. We have got the half-meter telescope images to take a direct look at, but more importantly, we have Mr. Well, I call him Mr. He's actually Dr. Duncan Cobb joining us. He's in the UK as well, and it's always fascinating to talk to Duncan. So please don't leave us. We are just going to leave you for 1 minute just so that we can show you the fantastic new Slooh app. Thank you very much.
Space Camera app. Your mission, if you choose to take it, is to image the night sky by commanding a worldwide network of robotic space cameras. Fly around the sky, zoom in and out, and touch category icons, launching your image bubble. Hit Start Mission, and you will be firing up an observatory somewhere in the world to image your object for your sky. Touch the magnify glass icon in the footer to better understand. Focus on Slooh's top missions, which are the best and brightest for the week. For additional updates on what's happening in the night sky, touch Advisories and visit our YouTube updates. Touch the broadcast icon to access our free live celestial programming, where we produce weekly shows tapping into worldwide observatory sites with a live broadcast team. The next show is already counting down, so make sure to come back to view. Once you book a mission, you can track its progress by touching the Spaceman icon in the HUD footer. Thank you for downloading our app, and go book a mission today.
Okay, and we are back. Now we are waiting still for Dr. Duncan Kopp to join us. But Bob, we said that in this second part of the show, we were going to be looking at in a little bit more detail about the risk that these near-Earth objects pose. Now, it's right to say that this particular asteroid that we're looking at tonight, it's classified as a near-Earth object, which can be asteroids and or comets. And there are these subcategories as well. So it's a near-Earth asteroid, but this particular one is also classed as a potentially hazardous asteroid. But we're saying it's 3.7 million miles away from us. Why? So why does it have this tag of being a potentially hazardous asteroid?
Good question. And while we answer that, we should say that now, in the next minute, now, when QE2 is at its closest to Earth. We've been waiting years for this object in its almost 4-year orbit, and with the game of clockwork gears meshing of Earth going around the sun, but now we are passing each other in space. This is the minute, right now. We are there right now as QE2 is now at its very closest to Earth. So those who are listening and who distrust the government perhaps, or who think that the governments are hiding the end of the world or Armageddon, we can tell you here at Slooh that if there was going to be anything happening, it would be this very minute. This is the closest approach. In a few seconds, we can say confidently that the asteroid is now pulling away from us. It has reached its closest point, and the distances will increase starting in about 10 seconds from now.
Excellent. Thank you, Bob, for pointing that one out to us. So talk to us about what categorizes these objects. How big do they need to be? Do they have to come within a certain distance?
Yes. Comes close to us, well, a miss means nothing, as we just saw this February 15th when we had asteroid 2012 DA14 come just 9/100ths of a lunar distance away from us. Distance is going to be a little bit of a closer shave when Apophis on April 13th, 2029 passes only as close as our Earth satellites, our geostationary Earth satellites. In fact, it's even be closer than that. It's going to pass within the orbits of our Earth satellites, and but a miss is a miss. Well, if it misses us, it misses us. That's it's like anything else that doesn't happen. When two planes, I know there are some pilots who listen to us. I'm a an airplane owner myself. I was just flying this morning, and I saw another plane only about a quarter mile from me, and we talked to each other, and we kept our separation. And as long as you don't hit each other, a quarter mile may as well be 1,000 miles, and that's the same thing with the asteroids. But we, especially after midnight, and see actual impacts of, and most of them are asteroid material. Some of them are bits of comets streaking into the atmosphere at an average speed of 20 miles a second or so. That's 40 times faster than a high-velocity rifle bullet, streaking through the atmosphere, turning into dust, making Earth a little bit heavier every year because of this accumulated material. And those are impacts with actual objects coming into our atmosphere. Of course, our atmosphere burns most of them safely to dust, but we don't have to tell you that some have penetrated roofs, have damaged property on Earth. And when we look back farther in time to June 30th, 1908, here were 50 miles of trees knocked flat. Fortunately, it was an area of Siberia with very low property values, but so we didn't have any cities or towns that were destroyed. But the larger of a time scale you look at, and now you see events that change the actual biosphere of Earth. And so, yes, these are important.
Bob, government has, or did take a warning, and it was in probably those heady days of the Hollywood blockbusters like Armageddon, and that did raise the profile, and the government gave NASA, JPL, quite a lot of money to go on the hunt for these things, and indeed they have found quite a large number of them. But I think what caught our eye last year, when we were covering, it was just at days' notices, these enormous chunks of rock were discovered literally just a couple of days before their closest approach to Earth. And that kind of caught us by surprise a little bit.
It really did. It really did.
I think.
And you're so right. For example, we had Asteroid 2013 ET. It was discovered on March 3rd of this year. We were just talking about a couple of months ago. We covered it on March 9th, just 6 days later. Now, this was an object about 300 feet wide. Now, it did miss us. It was more than twice as far away as the moon, but that's still pretty darn close in celestial terms. We spoke a little earlier about 2012 DA14 as we continue to show you images live from the Slooh Observatory showing you this asteroid QE2 as it at its closest approach to Earth, as it's now zooming past us. That's the clear round dot in the middle. The stars in the background look like streaks. We carried the asteroid Apophis last year. Now this was we covered that live. Actually, it was just January 9th. That's large as 3 football fields. And it was 3 weeks before that. We had an asteroid Tutatis 3 miles wide. That was twice the size of this one, and a little further away, 18 lunar distances away, but it was closer than that back about 9 years ago. It was only 4 lunar distances. So yes, absolutely, over and over and over again. Just last month and certainly last year, we've seen these closes approaching more. We're seeing them.
Now, it sounds like we're blowing our own sleep. It's really to be. It's just a especially one out of nowhere. They are making a closest approach to Earth, 2 days later. We did start seeing NASA pick up our particular coverage. A lot of media outlets started picking it up, and doing their own broadcasts. The objects were coming in, although one of the largest Apophis came. We were one of the few who actually covered that. And still crying out, they're begging to Congress or whoever it is who gives them their money. They still need more because, well, correct me if I'm wrong, I think they've only found 50% of the very large.
That's right, and of course it's not that you worry about.
Isn't it? Because the particular we found fewer and fewer. So the get, the fewer we have. I think it's the we only found one of those. Is that
Correct. Those are the ones that'll ruin you.
Yeah. So if something that did hit a city, what are the consequences, Bob?
That would destroy a city. The top is about 100,000 tons. An object that weighs more than that will not be slowed down in the least by our atmosphere. If an object weighs less, fortunately, all of the tiny ones do, the garden variety meteoroids that come into our atmosphere do, they're slowed down. If you're small enough, the garden variety meteoroid is slowed down to 250 miles an hour. That's the speed that most objects that will hit the Earth. Now remember, most of them are burned up into dust, so they don't even hit the Earth. But if they do hit the Earth, they're slowed only to a speed that will let them penetrate a roof and maybe one additional story, which is why so many people find them on the upper floor. Or if it's a one-story house, they'll find it on the main floor, not in the basement. They don't generally penetrate 2 full floors of a house because they're only going 250 miles an hour, even though they're starting off typically at about 70,000 miles an hour. But if an object is heavier than 100,000 tons, and you don't have to be that large to do it, the object you were just talking about, Paul, would do it. Then it hits Earth at full cosmic velocity. And the impact energy, the kinetic energy, is always equal to the mass times the speed squared. So the speed is more important than the mass, and the speed is enormous if it's large enough so that our atmosphere doesn't slow it down. And that's the problem with large objects like the one that we're imaging live now. This is well over 100,000 tons, and so if this impacted Earth, it would impact us at full cosmic velocity.
Thank you for that. Well, we have another guest joining us. I'm going to introduce him in a second. But just to let you know, while Bob was talking there, you were looking at a lot of the time-lapse movies that we've put together from our various shows on some of these, newly discovered asteroids that came very, very close to Earth. We've been covering them since 2004. There was one that actually came in. We imaged it 2 hours before it entered the atmosphere above the deserts in, I think it was the Sudanese deserts in Africa. And we grabbed, Slooh members actually grabbed images, because don't forget, the telescopes that we're using tonight to bring you these live images can be used by anybody. So you can sign up for a Slooh membership and you get to control these telescopes every single night. And this kind of goes a little bit on the conspiracy theories. Whenever we hear somebody start talking about NASA and covering up these asteroid discoveries and stuff like that, we say, join Slooh. You point the telescope wherever you want it to be to search for an object. And we did this last year because I'm not sure if we know that quite a few people joined us last year for the end of the world. Slooh covered the end of the world live last year. We were bringing you live images, and we were saying, people were saying this planet Nibiru and all sorts of stuff were going to hit Earth, but we actually brought you live views of the heavens to disprove all of this stuff. But anyway, without further ado, I am going to welcome in our new guest, Dr. Duncan Kopp. Now, Duncan, you're not usually referred to as the doctor, but I thought I'd better pop it in there just in case. But Duncan, just in case you don't know who Duncan Kopp is, he's an award-winning film and TV producer. I think it's Patrick Palucci, who's producing our show tonight, will understand this. I think, Duncan, quite often the producer is the person who doesn't get known. But our viewers out there, chances are they've probably seen one of your documentaries, and certainly my favorite is In the Shadow of the Moon, and I would really say to all of our viewers tonight, if you haven't seen Duncan's film In the Shadow of the Moon, it's one of the most fascinating stories told in documentary format that I've ever seen. So Duncan, welcome to the show tonight.
Thank you, Paul. Good to talk to you again. And hello, Bob. Good to hear your voice again.
Hi, Duncan. Always a pleasure to see you.
Now, Duncan has many, many years ago, not that many, I guess, but you got a PhD in astronomy and planetary geology and a lot of stuff like that. Now, I need to go and tidy up some of the live images and make sure that we're pointing correctly at the observatory. And what we really wanted to talk about in the last 15 to 20 minutes of the show, by the way, we will be taking questions. If anybody's on the Slooh homepage, just click the Slooh Conversations button and our producer will feed in any questions that you've got about this particular asteroid or any particular asteroid and this whole topic. But Duncan and Bob, I wonder if you could both pick up this baton and actually discuss, I think part of, we've already been talking about what Slooh have done to kind of bring this message of there are still such current risks out there, but also what can we do about it? What is being done about it to catch and discover these last asteroids that are out there? And then if we did find one that was on a collision course with Earth, what could we actually do about it today?
Duncan, you want to take this?
Yeah, sure. I think the first thing to talk about is when you're talking about threats from space, and in particular these near-Earth asteroids, size really matters. It's all to do with how big these things are. That's the way I understand it. And how many there are as well. And, just to sort of give you some facts and figures, if you had something about 40 meters in diameter, that's about the size of, I don't know, an office block or something like that. That's a critical size because anything smaller than that, and the Earth offers up its own natural protection. It's got a shield, and that shield is our atmosphere. And what happens is anything smaller than that normally burns up or fragments in the atmosphere. Anything bigger than about 40 meters, and then you're starting to cause problems, really. And that's because these objects are big enough to get through and hit the ground. And anything bigger than about, well, say 40 meters or so, if it hits the ground, the kind of energy you're going to dissipate when this thing smashes into us is something like 3 megatons. And scaling that up, if you had something in the order of about 2 kilometers in diameter, the impact energy then is something like 1 million megatons. And that's massive. And I think taking it to the extreme, some of the biggest impactors we know, something that killed the dinosaurs, something about 15 kilometers in diameter, something like that, about 100 million megatons. So it's all to do with size, and it's that crossover. Something smaller than 40 meters in diameter is probably going to burn up or fracture in the Earth's atmosphere. Something bigger is probably going to get through. Now, once you understand that, you really want to start thinking about, well, how many are there out there? And I think the current estimate at the moment is there's about 1,000 near-Earth asteroids that are known that are larger than 1 kilometer in diameter. So in fact, we've got a pretty good handle on the big ones, okay? But it's those smaller ones that are really the dangerous ones, and the ones that they've got the term city killers because they have the potential to hit and do a lot of damage. And it's estimated there are tens of thousands of those city killer size asteroids out there, and to detect all of them could take a very long time. You can't see near-Earth asteroids. If you could see a near-Earth asteroid with your naked eye, I'm talking about the naked eye now, you can't see near-Earth asteroids with the naked eye. If you could, you should duck, because basically this thing is about to hit you.
Very good, Duncan.
Them is with telescopes, and to have a dedicated sort of detection program, if you like. And in fact, when QE2 was discovered in 1998, that was the same year that NASA actually implemented a device, a safeguard, if you like, to go out and actually look for these things.
Don't-
So the upshot is, here's the rub, you can't protect yourself really against something you can't see. And you need to be able to try and detect as many of these things as you can. And if there's, tens of thousands of relatively small ones out there, that's a pretty tall order. There's a lot to do. There's a lot to try and understand, try and learn these things, try and learn just what these risks could be. So, we've still got a lot to learn.
We do, and there are a couple of really interesting points. That was really well-timed commentary there, Duncan, because Bob and I were just talking about the size that these objects have to be to cause a lot of damage. And one of the things you said there was that we have our natural shield, we have our atmosphere, Earth's atmosphere, and a lot of the smaller objects do actually burn up. But we saw a classic example of what happens to a smaller object when for a body such as the moon that doesn't have an atmosphere. Only a couple of weeks ago, the impact of a fairly small chunk of rock, a fairly small meteoroid, hit the moon in an incredible flash, and it caused a crater of about 20 meters. Now, that same size object would never have made it through Earth's atmosphere. But
absolutely, yes.
You also there, Duncan, gave some figures about how long it could take to discover all of these smaller objects. Now, on the 14th of May, there was a Congressional House Science Committee meeting that took place, and it was NASA Administrator Charles Bolden was there. And while acknowledging that their funding to deal with the asteroid threat had risen from $5 million to $20 million over the last couple of years, he did say that his current estimate was that it would take until 2030 to catalogue 90% of the near-Earth objects between 140 meters and 1 kilometer in diameter. At the same time, they were saying that if Congress would give them $500 million to $750 million, they could put a new space telescope up there, which would hunt specifically for these smaller asteroids, and at that cost, it would only reduce that discovery period by 6 to 8 years. So that didn't sound like great value to me. I don't know what you think about that, Bob.
Yes, of course. Now, we're astronomers, so of course we want as much as we can. The more money, the better. And in fact, somebody is just asking now, we have a 12-year-old who's asking us how close to Earth, and this is something we could discover if we had a bigger telescope and more resources. Somebody's 12-year-old is just asking us now here at Slooh, how close to Earth is this asteroid and how big is it? And a 5-year-old's asking, why do asteroids that fly by the Earth go so fast? So if we could just take these two questions from these children, this would be, and they can fortunately be answered very quickly. This is about 3.6 million miles. It just passed at its closest exactly 20 minutes ago, and that's about 15 times the distance of the moon to Earth. So safe distance. It's going so fast because everything in space goes so fast. Paul was just talking about the impact on the moon 2 months ago of an object traveling at 56,000 miles an hour, about 100,000 kilometers per hour. And this is typical. Earth travels at about 19 miles per second, and anything at this distance from the sun will be traveling at roughly that speed. So what we're watching tonight, QE2, this asteroid is also traveling at roughly 20 miles per second, 40 times faster than a high-velocity rifle bullet. And how fast it impacts us really depends on whether we're at that moment going in the same direction. In other words, whether it's just kind of barely catching up to us from behind, or whether it happens to be meeting us head-on in our orbit as we go around the sun. Is its path one that's going to make for a head-on collision? Of course, that's going to be a lot more dangerous than this. And one final question we're getting, the producer is saying somebody is asking whether there will be meteor showers associated with this tonight, and the answer is no, because it is not crossing our orbit. It's coming close, but not crossing our orbit. So no cigar, plus it's not shedding material. Comets tend to shed material like an overloaded garbage truck or gravel truck, and but the asteroids don't. It's not shedding material, and so no meteor shower from this.
Just to let everybody know, we have actually extended the show because Duncan couldn't join us at the top of the hour. We have extended the show by 10 minutes. We're still going to be bringing you live images throughout. We've got them tonight from the Slooh Canary Islands Observatory. We're using 2 telescopes there. We're using our HIMAG telescope, and we're using our half-meter telescope, which is bringing us some fabulous views. Don't forget, the half-meter telescope view is a fixed star field, so hopefully you've been watching the small asteroid as it goes across that particular image. Now, those same telescopes you can control. Anybody can control these either through a Slooh membership. You sign up, you buy a membership, and you control these fabulous telescopes. Point them wherever you like. I'll tell you, it's great from even the beginner's point of view, but even if you want to do really complex science, we've got a group of members who are searching for comets at the moment. It's a fascinating project. But if you don't want to join up to all of that extent, we have just launched this new app, and I'll tell you, it's such great fun, not only for kids, but I actually bought an iPad specifically to use it, and it literally gives you single finger control of the Slooh space telescope.
Paul, you bought a Mac product?
I did. It's the only one that has ever entered my house, and it was painful. It was very, very painful, but it was allowed in my house specifically to use the Slooh iPad app. And frankly, we make no apology for doing this little bit of promotion during our free live public shows, because, you know, it costs a lot of money to do this. It costs money to bring experts on. It costs money to keep the observatory running so that we can bring you these fabulous live images. And it's down to Slooh members who pay their subscriptions to join Slooh. That helps us do these live events, and also in-app purchases. So when you control the telescope and have your own very own image of any celestial object out there virtually,
including this one, yes.
Exactly. It helps. It helps us to bring this kind of live coverage out to a wider public audience. So a big thank you to everybody out there, all the Slooh members and also app users. And if you haven't already downloaded the Slooh iPad app, you should do so. It's actually a virtual sky, so it's free to download, and it helps you learn the sky and where things are. Anyway, sorry for that little interruption,
okay,
James.
Now, Bob Berman here with a question for Duncan. Now, I'd like to ask a follow-up question to the one you raised, Paul, and that is, you were starting to ask him, and I don't think I got a chance to answer it, about whether it's worth spending all this extra money on a dedicated telescope, or would the money be better spent on, let's say, an educational program about LDL cholesterol reduction? Which is how great is the danger compared to other things in life? Is this really money well spent? Question to Duncan.
I think so. I think it is money well spent, because I think one of you mentioned earlier on in the show, we're talking about $20 million, which sounds like a lot of money, but to be honest, in science and research, it's an absolute drop in the ocean. Yeah. We're talking about something that potentially could deliver the best result value for money you could possibly ask for, which is protection at the end of the day. Not just scientific investigation, but protection. And I think that's a very important thing to do. We all go out every year and spend money on insurance. We insure our house, we insure our car, we insure our lives. I think we should take a little bit of insurance out against the planet. I don't think it's a great deal to ask. It's a fraction of money when you look at it in that respect. So I think it is money well spent. And I learned quite a sobering fact the other day, which you were talking a little earlier about the meteor that exploded over Russia. February 15th, which was just phenomenal. Something like an energy of 0.5 megaton, something like that. Had that piece of rock not fragmented, had it actually got through and hit the ground, it would have hit, it's been calculated, with something like 20, energy impact of something like 20 megatons. That doesn't sound like much, but 20 megatons is roughly all the explosive used in World War II. And so I think that sort of puts things in perspective, because you wouldn't have been talking about thousands of injuries, you would have been talking about thousands of deaths. Yeah. And you know, it's very interesting when something like this happens. You know, we're cocooned here on our world, and we all go about our daily lives, and until something happens that really grabs our attention, it's very difficult for us to comprehend statistically just how dangerous these things are. And I don't think there's any harm in spending a little bit of money to find out a little bit more.
And I think that Russian event, Duncan, was really important, and it did prompt this meeting of the House Science Committee in Congress on the 14th of May. And they had both the White House science advisor there, John Holdren, and he said, if we want to save the planet, because I think that's what we're talking about, then we have to get together and decide how we're going to execute that plan. And he also went on to say, I believe, that that governments could either pay now to start or to progress with some speed the program of discovery, and also what to do if one of these things does come within impact distance of Earth, or they can pay the price of the cleanup after one of these things. And I think the Russian event suddenly took us from looking at small white dots in images of these objects that are very difficult to comprehend. You know, you can say something's the size of a city block, but, you know, do we really, can we really comprehend that kind of stuff when it's traveling at such extraordinary speeds? And it's that speed that's the thing that gives these things their energy. But seeing something like that, and covered from all of those car dashboard cameras, seeing it from so many different perspectives, it was something that we could relate to, wasn't it? Seeing this enormous thing.
Totally.
Yeah. And so that we don't
believing, Paul.
It is.
Yes.
Yeah.
And let's not make Duncan seem like he's wrong, because he was talking about the size matters before, and now Paul is saying that speed is more important, and this is one of those wonderful cases where both of you
both
are right.
People are right. Yeah.
Because with the larger mass, the object can survive its trip through the atmosphere and retain its cosmic speed. And even though kinetic energy is velocity squared times the mass, so, you know, on paper the velocity is much more important than the mass is, but it's the mass that allows it to retain its velocity and impact us at the high speed. So it still ultimately comes down to the mass, really.
Combination, yeah.
Yeah.
So I don't know if either of you watched earlier. I do. We're really not blowing our own horn, but frankly, before Slooh really started covering these near-Earth asteroids, you know, in a lot of detail last year, we were picking up, and the great thing about Slooh is we own these telescopes at this world-class observatory. We've got nothing whatsoever to do with governments or NASA, so you can kiss goodbye any conspiracy theory or anyone trying to hide things up. Slooh members can point these telescopes wherever they want. And when we started covering these things last year, we did, within a few months, start seeing a lot of other activities when new asteroids were discovered, to the point where NASA actually started giving their own live coverage. And I don't know whether you both saw, but earlier on this evening, 2 hours before the live event started, there was a White House hangout of White House talking about this particular asteroid, and also the measures that can be put in place. And there are a couple of initiatives, aren't there, out there. Duncan, I think you were talking about B16.
Yeah, I watched that hangout a couple of hours ago. I was really quite with regards to, I was a kid, you know, it's just expensive, just impossible. If you wanted a real, and even if you could afford it, here in Britain, the was going to be cloudy. All about an astronomer. The key is, you know, for able to use world-class telescopes, and you've got access to people who know what to show you and know what they're talking about. That's what I really like about this little setup that you know you've got going, and also it's also very interesting from my point of view because when I started my profession, this kind of technology did not exist. The ability to be able to get to a much wider audience in a very simple way, you know, using our computers and using Hangouts and using the internet, just wasn't around. And, you know, it's wonderful to see how we're able to embrace that technology now and get these really interesting, salient points out to people who are interested. And I think, you know, has really trailblazed in that arena.
Well, there's
great to see.
There's an interesting comparison at the moment, actually, Duncan, that there are a group of billionaires out there. You may have seen them. I think one of them's ex-Google or something like that, so I better not say too much, otherwise we might be cut off from the search engine. But it's a group of engineers who are currently going out to the public to try and raise $1 million so that they can put this kind of tiny space telescope into space in a couple of years' time.
Yes.
And what people can do, if they contribute $200 to that million, then each person who does that can take one astro image of whatever object they like. But I would just remind people that, frankly, well, first of all, why are billionaires asking the general public for $1 million? But secondly, if you can afford $200, why not have a year and a quarter's worth of Slooh membership to control the Slooh telescopes every single night for that period of time? Because it is important. These are not telescopes that are just in somebody's backyard. We are at a world-class observatory site, and people might get fed up with me saying that, but this is 8,000 feet up in the air. It's an unmanned robotic observatory. Now, tonight, I'm controlling it from England. And this goes to what you're saying, Duncan, you know, the technology which is available. I'm sitting here in England, controlling a telescope, sitting on top of a volcano in the Atlantic Ocean, several thousand miles away from me. Those images are then being streamed out in real time to all of our viewers. Once again, a global audience. And it's this kind of dissemination of information which I think, to me, always dismisses a lot of the conspiracy theories that we see around this type of subject of NASA hiding stuff up. You know, there are just too many eyes on the sky, aren't there?
Okay.
At the moment?
If you're going to be bragging about Slooh, then let me jump in and say the thing that I'm most impressed by, Bob Berman again here, is that simply the proprietary technology that allows these stunning full-color images in 5 minutes. In other words, a subscriber who is going to use the telescope for 5 minutes is going to obtain a detailed color image of, let's say, colliding galaxies or Jupiter showing its moons going around it, and
people can do that in the app now, Bob, as well.
Yes, and that's astonishing to be able to obtain an image of that quality in that the shorter time.
Yeah, but you know, Slooh actually has patented technology for that, and in fact, I believe some lawyers are looking at a couple of other people who might be infringing on that. But anyway, let's get back to the story tonight. Duncan, you may have heard me if you were listening in on the show right at the very beginning. One of the things that intrigued me about this particular asteroid is, as we've said, it was discovered in 1998 by one of the big search programs, but only last night, or actually I think it was the night before, 2 nights before it makes its closest approach, with some new radar observations, an object that we've known about for nearly 15 years, we discover that it's got a little chunk of rock. How big is it, gents? I think it was
2,000 feet.
2,000 feet. There's an asteroid 2,000 feet orbiting 1998. and we're showing the radar images of it now. That really stunned me. I mean, we were doing this show anyway because we cover all of these events. And what did you think about that? Doesn't it really kick home to us that although we believe we understand a lot of this stuff, our knowledge is actually full of holes, isn't it?
Totally. Listen, expect the unexpected. That's what science
Yes.
is all. That's what science is all about. I mean, and especially in astronomy, there are weird and wonderful things you can't even, imagine to start discussing because just haven't been discovered yet. When I was doing my research with the Magellan mission looking at Venus, we mapped the planet down to 120 meters, and we have 99% of the planet covered. And that is way, way more than the Earth, because 2/3 of the Earth is covered by oceans, and underneath those oceans, we really have no idea what's there in that kind of resolution. And the kind of imagery that we were getting back flummoxed us. Every day we would have a new image, and we were looking at geological formations we'd never seen before. And that's just beauty, that's science beauty encapsulated, because you never know what you're going to find, you never know what you're going to see.
And while we're talking about images, let's not forget that we are looking at live images right now of this asteroid as it has just passed its closest to Earth. That's what we're seeing. That's what all of our viewers are seeing live from the Slooh space camera.
Going back, Duncan, on what you were saying, Slooh members have had some marvellous treats just over the last couple of weeks of surprises. We've got Comet Pan-STARRS. It's not its full name, we won't go into all of that now, but Comet Pan-STARRS was one of the good ones this year. And suddenly, 2 weeks ago, I think it was, it developed what's called an anti-tail, which is it appears like an enormous spike of a tail actually heading towards the sun. And we've seen all sorts of things over the last 6 months. We've seen an asteroid or comet hit Jupiter and explode in its upper atmosphere. We've seen comets outburst totally unexpectedly. We've seen them fragment. We've seen so many unexpected sights through these telescopes every single night. And Slooh members, even after this show, they're going to carry on watching this particular near-Earth asteroid 1998 QE2 as it whizzes past the Earth on this particular round. Now, somebody did ask, can the Hubble capture QE2? Well, I'll hand over to Bob, but I believe I'm correct, Bob, by saying that most of these asteroids are too small for any visual telescope, optical telescope, to resolve any detail on. So that's why we have to wait for the big radio telescopes to image these things, isn't it?
Exactly true. What we're seeing now is as good as any telescope on Earth can show. What the Slooh space camera is showing at this moment. There it is. I mean, this is a faint object. If you had a good backyard telescope, it would be at the limit of your visibility, even if you had it pointing in the right direction, which, by the way, is in the direction towards Libra and Hydra in the southern sky.
Yeah. So, well, the other things, of course, that we've seen live on Slooh fairly recently are eclipses. We've got another solar eclipse coming up at the end of the year. Don't forget, Mr. Bob Berman is an astronomy author, and his recent book is an absolute fabulous read, The Sun's Heartbeat. Bob sent me a copy over for Christmas, and thank you very much for that, Bob.
A pleasure,
Duncan, what have you got on the cards? What
Program about economics at the moment, which is slightly.
Oh, right. Oh, well, you can go now, thank you. We're not interested in that kind of stuff.
Slightly different from what I'm used to, but there's always a good opportunity with regards to science documentary making, because there's so many great things out there, and it's a bit like using Slooh. The more you look for things, the more interesting things you find, really. So. I'm always on the lookout for good ideas, and it's always a joy to be able to make them into engaging films and try and hope they reach a a broader audience.
Well, we certainly look forward to your next production, because I don't think I've ever seen any documentary or film with your name associated to it that I haven't absolutely lapped up. And I would remind people that if they haven't seen one of Duncan's documentaries, In the Shadow of the Moon, you've got to look at that. It's absolutely fantastic. Don't forget that you can also catch Bob Berman's regular column in Astronomy magazine every month, and Bob joins us for a lot of shows. Hopefully we can have Duncan join us for a lot more as well. Bob, have you got any last words before I let Duncan say some last words? And then I've got a single quote to finish the show with tonight.
Well, I would just say this was an honor and a pleasure, and there's the image. I'm just still enjoying it, that of this asteroid 1.7 miles across, as during our show it whizzed at its closest approach past Earth and is now heading safely off into space. Really a pleasure to see it, and I'm glad we had clear weather for the Slooh space cameras to bring these live images. And Paul, you've done a masterful job as always, controlling the telescope and getting these images. I know capturing a moving object, it's like capturing a bullet in flight, but you pulled it off again. Good job.
I'm sorry if sometimes I don't sound very attentive, but I'm kind of trying to do two jobs at once. So, Duncan, have you got any last words for us this evening?
Well, I just want to echo Bob's sentiments. Paul, honestly, bringing these pictures into our homes is just incredible. I mean, I get the kind of buzz that I always used to get when I was young. You know, the very first time you see Jupiter's moons or Saturn's rings, and Slooh just is able to do that, brings it right into my office here in my home in London, and I'm able to watch things real time. I just find that so exciting. So thank you so much for all your time and effort in doing that. It's brilliant, well, really brilliant.
Many thanks for joining us on tonight's show. It's always a pleasure to have both of you on our shows here at Slooh Space Camera. So I also want to put a big thank you out there to Mr. Patrick Paolucci, who's been producing tonight's show. Tonight's show has been the first one that we've tried to do using a new system, and it looks like it's worked quite well. It also enables us to broadcast in high definition, which is pretty cool. And I've just got this one last quote that I'm going to finish off the show with, because I saw it in one of the articles talking about Asteroid 1998 QE2, which is the object that we've been looking at tonight live from the Slooh Canary Islands Observatory. And it paraphrases the science fiction writer Larry Niven. And he said, "We can hear the asteroid whisper as we track its progress across the sky, asking humanity, how's that space program coming along?" So on that note, let's hope that we do find some ways of maybe nudging one of these little objects off to one side if it starts heading a little bit too close to Earth. So thank you everybody who's kept with us for the duration of the show. I'm Paul Cox. This has been Slooh Space Camera. Thank you very much to my guests, Mr. Bob Berman, Mr. Duncan Kopp, and our producer, Patrick Paolucci tonight. Please support Slooh. Join up for a membership to control these fabulous telescopes, or download the Slooh iPad app. It's free to download and it's really great fun. So good night to all of you. Thank you very much.
Good night.
Good night.